Okay, so now that we've seen how while loops are structured, let's look at the do while loop structure. So let's go ahead and draw a flow chart for these kinds of loops. Let's start with a while loop again. All right, so let's say you have a start of a program. Okay. Then what you have typically are some sort of declarations, right? Then you may have some sort of an input or an assignment. Whatever you do here, so I'm just going to put some dots here, which means it could be anything you'll be doing here. Somewhere down the line, you're going to encounter a situation where you're going to need a loop. And I'm going to simulate a while loop first. So for the while loop, the first thing you're going to do is ask a question. If it's true, then you will do certain things as well, whatever they are. But something special you're going to be doing in here to control your loop, right? So, and that keeps you in this loop right here. So this is really how the while loop structure looks like. And then let's say it's false. Then you continue on with your program to the end of the program right here. So, and that's typically how a while loop works. Okay. So one of the things you might want to do either here or here is prime the loop, which means you set some value that you are testing right here within the condition. Based on what you did here. However, while you're in here, you need to have some sort of loop control. Otherwise, you'll be stuck in that loop forever. Right? So these are some of the prerequisites for a while loop. Now, the important part is for a while loop too, is that you're asking a question, then you loop, or then you execute what's in the body of the loop. So the condition test comes before the actual execution of the body of the loop. What does that mean? That means if the condition tests it out to be negative, which means false, then you will just test here and go straight down this flow. So you will never execute this loop if the condition is false. Right? So you could run this program over and over, and every time the condition is false, guess what? You will never execute that. The body of the loop, whatever is in here, plus the whatever you need to do for the loop control. Okay? So the important part again is that the body of the while loop may or may not execute. Now, what if you wanted the body of the loop to execute at least once? Right? So that means you need to encounter the body of the loop before the condition. And that is where a do while loop comes in. So a do while loop will be structured this way. So let's say we have a start of a program here. Let's say we have some sort of declaration, right? So, and again, it depends on your program. And you're going down, and then suddenly what you're going to find yourself is that you're going to be doing a body of a loop right here. Okay, so this here will be the body of the loop. Right here. Now the body of the loop on the other end is this way, right here. And then you ask a question. So somewhere right here, between here and here, you will have executed the body of the loop before you test for the condition. Now, if it's true, if the condition is true, guess what's going to happen? Notice this line here. It's a straight line. There is nothing in this line like you would here. Which means, guess what it's doing? It's going back to the body of the loop and executing it one more time. And then the test has to be evaluated again. Now, if the test yields a false, then you continue on with your program to the end here. And that's typically a do-while loop. So this would be a do-while loop. Now notice the word do. So that means do this before you test for the condition. Then go ahead and test the condition. If it's true, go ahead and loop, which means come back to the connector right here and re-execute any of the pieces that are included in the body of the loop. Now, one big advantage of do-while loop is you could do away with priming. You don't need to prime. Why? Because you will run this at least once. Okay? So within this, however, you need to have some sort of a loop control as well. Otherwise, you'll never get out. So somewhere in the body of the loop, the value that your condition is based upon must be able to be altered within the body of the loop or do-while loop. Else, what's going to happen if it's always, let's say, true, then you will always loop. If it's always false, no matter what you do here, then you will only execute this once and get out. So what's the point of having a loop if you do so? You want that flexibility of that variable's value to be either true or false within the body of the loop, where you may have a specific area where you had a loop control. And that loop control could be either a process or an input that changes the value of the variable you're testing against within the condition test. And that's how your do-while loop will execute properly. So let's go ahead and do an example with a do-while loop, right? So we're going to write some code now based on a do-while loop structure. So let me just get my keyboard down here. Okay, minimize this. And we're going to start a new program. And this would be example 31.cpp. Use of do-while loop. Okay. This is still an introduction to looping. Okay. All right. So include IOStream using namespace std. And again, I will show you in the future when it's a good idea to keep that in place or not, or what is it exactly for in due time. So int main, we know main returns an integer back to the operating system. That's your return 0 item. So that's the 0 being returned to the operating system once your main program ends. And again, what we're going to be doing eventually after we finish looping is we're going to have other functions other than main. Everything we've done so far up to example 31 and maybe the next video as well are going to be, we're going to focus where our code is going to be focused within the stack main, right? Or the function main. Eventually what's going to happen is we're going to need other functions. We're going to make our programs more procedural. So this would be the end of the program. Typically, within the end of the program, you want to hold the screen. Now, I've shown you another way to hold the screen in case you're in Linux or Unix, okay? Right now, I'm in a Windows environment, so this will work just fine, okay? So, I want to do a do-while loop. A good example of a do-while loop would be something about, let's say we want to add a few numbers. We want to accumulate numbers. But at least we're going to go through it at least once. Remember, with the do-while loop, the body of the loop has to be executed once. So let's say we have an int accum equals 0, right? And let's say we have int choice equals 0. It doesn't matter what your choice is. Actually, we don't even need to prime, right? So you could initialize it to 0 if you're doing a while loop. Choice is going to allow me to, I want to add one more number to the accumulator. Since I'm doing a do-while loop, there's no need to prime it. Why? Because here's what's going to happen. Do, notice the structure, while, and notice what I'm going to do here, while choice equals 0, for example, stay there. And notice now I'm going to put a semicolon right here. So this is the do-while construct. So now I need to write something inside the loop body. Okay? And I need to have full control over choice to either give it a value of 0 to remain in the loop or give it any other value to get out of the loop. Okay? So what I'm going to do here is accumulate. So first accum equals accum plus 1. Now we've seen this before. This adds a 1 every time. Now there is an alternate way to do this. If you're simply going to add 1, you could do accum plus plus. This is one way to do it. Another way to do it is accum plus equals 1 and semicolon. That adds a 1. So all these three variants in our syntax will do the same thing. The 1 is the offset. How much are you adding to accum as an integer? I'm adding a 1. So plus equal 1 is one way to write it. So you could do something like this. Accum plus plus is another one. You could do accum equals accum, previous accum plus 1. So this would be the traditional incrementation by 1. So you could choose any of these to accumulate if you're doing an offset of 1 every time. Okay? So now, that's great. That's the job of this loop. But we need to control this loop now. So the accum plus equal 1 is what this loop is supposed to be doing every time you run the body of the loop. The key now, you need to control this loop. So maybe something like this. Cout, enter 0 to add another 1 to the accumulator. Or any other number to exit. Let's say that's what you want to do. So cin. Now you're in full control of choice, which is the variable you're using to control the loop. So this here will be the loop control. Right? And here at the bottom is your loop condition. What we've done away with is the priming of the loop. Since we have full access to the variable within the body of the loop, since you're going to run it at least once. Now, once you're out of the loop, it'll be interesting to see, okay, what happened? Okay, what's the effect of running this loop? Well, you know, its job was to accumulate. Great, well then show what you've accumulated. So cout the value of the accumulator variable accum equals, you could show what it is. Right? So this gives us a chance to see what you've accumulated as you ran this loop. Now, the nice thing about this loop, you can run it as long as you want while the program is running at runtime. As long as you're entering 0, you stay in the loop and you keep accumulating. As soon as you enter any value other than 0, that stops the loop, right? But you have to be careful, right? So, because once you enter -1 or 3 or something, the evaluation is done right here. So it's not going to go back to evaluate, because remember, your loop condition is at the bottom, okay? Not at the top like a while loop. Notice a while loop, you start with a while loop, don't put a semicolon there, because the body of the loop is afterward. For a do while loop, the body of the loop is before the loop condition. Okay? And notice the keyword do here. Okay. All right, so let's compile and run this program. And this will be example 31. Okay, so let's make this a little bigger so you can actually see what we're doing. It's about 28, it's fine. And there you have it. So it's asking me, enter a 0 to add another 1 to the accumulator, or any other number to exit. Well, let's say I entered 2. And notice that the accumulator value is at least 1. Plus equal 1, added 1 to the accumulator. Let's run this again. And this time I'm going to put 0. And it's going to ask me again. So as you notice that it's keeping me in the loop since the condition for the while loop is true, for the do while loop, that is. So I'm going to enter another 0. I'm going to enter another 0. And you keep going and do this as long as you want. This is all under your control. Right? So there is no set value that says you're going to be looping 5 or 6 times. This is all based on whatever conditions or circumstances you're running this program for, right? So you could be collecting temperatures, you could be doing a whole bunch of things. You could stop after 3 days of collecting temperatures, you could stop at 4 days of collecting temperatures. It's all up to you. So this gives you flexibility in terms of how many times you're going to iterate through a set of data collections. So I'm going to do a -1 here. So that's going to kick me out. And notice the accumulator by now accumulated to 5, right? Started out at 0. You added 1 on the first iteration. 2, 3, 4, 5. So every time you added 1, and the accumulator did just that, accumulated, right? All right, so that is how a do-while loop behaves and works. So again, let's look at the flow chart. As you can see, the body of the loop is executed at least once before you actually test for the condition. Should that condition be true, you're going to go back and re-execute whatever is in the body of the loop. And remember, within the body of the loop, you need to have some sort of a loop control to alter the value for the condition that you're testing against. So that way you have the ability to get out in case that variable test yields a false value or a Boolean false, and you're out, and then you can continue on with your program. Okay? All right, so on this, we're going to next do another example with for loop. So we get to see when do we use a for loop, right? Which is kind of a while loop, but much more compact, and is typically used when you actually know kind of ahead of time how many times you're going to loop. So there are scenarios in which while loops are needed versus for loops, and there are times where for loops are much better suited to a situation than a while loop. Do while loops are special. These can be used when you at least need to run the body of the loop once. Okay? So that's what makes do while loops different than a while loop or a for loop. Okay? All right, fantastic. So I will see you again for loops.